Two storms for the eastern half of the country and still watching the potential for an East Coast snowstorm for Sunday into Monday. And I'm telling you, Sunday into Monday is the one to watch. It is going to be a very, very close call regardless. Either way, it's going to be a very close call. So let's take a look at the upper levels for today and tomorrow's storm for the Northeast. For this one, we will only look at the Euro model just because both the GFS and the Euro are practically the same. So for simplicity purposes, we're just going to look at the European model. And I want to show you here what we're going to be dealing with. You're going to get some of this energy here. Let me move this back here just a little bit. You get some of this energy here sneaking out ahead of the main trough here. And that's going to result in some widespread rain and snow across interior portions of the Northeast. And that's going to result in, like I said, some snow, mostly confined to the very interior portions of the Northeast. And I'll show you the snowfall map here in a second. And that's going to be a result of this energy sneaking out ahead. Plus, you get this upper level divergence that's enhanced where the isobars go like this. So you're going to get some upper level divergence that is enhanced by that piece of energy right here. And that's going to bring some snow and some rain to the Northeast region through today and tomorrow. I want to show you also that this southern piece of energy, this is the one that we were looking at when we were talking about the potential for an East Coast snowstorm for the end of this week. This is the system that we were watching. It was how this trough set up. It was the tilt of the trough that it was going to be dependent on. And it was how this energy reacted to the shape of the trough. You get two lobes of energy. You get this one down here and you get this one up here. That's why we're dealing with two separate systems. So this piece of energy and this piece of energy stayed separate rather than kind of combining and dropping into one another and then getting out ahead of the main trough. They're staying separate. This storm is heading up this way, and then this piece of energy is going to be heading off the coast like this, and it will keep the storm offshore, the main storm offshore. And I'll show you that here on the surface map. And there's that storm. It stays offshore. It does not interact with that cold air that is in place, and storm stays off the coast. No East Coast snowstorm with this one, but Sunday is the one to watch. But first, I want to show you what the snowfall map looks like for the Northeast for this first storm here. So let me show you that quick. So here is the snowfall map for the first storm. And you see a nice region of a coating to 1 inch here across portions of Western PA, New York, up into Maine. And then I put a region of 1 to 3, and that's a pretty big region of 1 to 3 across Northeast Ohio, far northwestern PA, across portions of the Appalachian Mountains, all the way up into Maine and into New York and New Hampshire and Vermont. And then as you get closer to the Great Lakes, I put a region of 3 to 6 and then a region of 6 to 12 here. And I think that's going to be because you're going to get some lake effect snow to kick up, but then it's also going to be more enhanced, and you're going to get a longer period of snow versus rain changing to snow. So I do think that the best chance for 6 to 12 does remain in far northeastern Ohio, northwestern PA, so Erie County, and then also into Buffalo and into western New York. And that's where the most snow is going to be seen out of this. It's not going to be a huge system, but it's going to be impactful for some. But most of it, unfortunately, stays offshore because the energy did not drop down into that southern piece and get guided up the coast. But I want to show you now Sunday, because Sunday is the best potential. Here is the snow potential for Sunday. I made this morning. This is for January 18th through the 19th, so Sunday into Monday. And I put the snow potential, I think really, I could cut this back a little bit and move this blue line further southeast into Pennsylvania, into New York, and less. But I'm still keeping it like this for right now, just because a lot can change still. The models are kind of all over the place, but let's dive into what the models are showing, because I think that this one is going to be interesting. It's going to be a very close call regardless, and I think we need to talk about it. All right, so here is the Euro model. This is the 500 millibar and vorticity map. And this is the piece of energy up here across the upper Midwest. It's diving down southward. That's going to result in the potential for snow across the East Coast on Sunday into Monday. And I want to show you what the differences look like between the models. So here you have a positively tilted trough. As you can see, it's going from northeast to southwest, and it moves down in just like this. And this is the energy that you want to watch. if we can get a negatively tilted trough or even a neutrally tilted trough, but if you really want an East Coast snowstorm, you want it to be negative, and that will guide the surface storm back up along the East Coast. But this one, you can see it stays more neutral, and the storm gets pushed out to sea. I want to show you what it looks like at the surface here. Show you at the surface. And here is the storm. It stays offshore, but very close. It's very close. I mean, it can still change. I mean, just a small difference in the upper levels can make a huge difference at the surface. I mean, you can see here, even with this solution, snow is clipping the Carolina coast and very, very close for New England and portions of the Northeast. But I want to show you what the GFS is showing, and this is the most recent run of the GFS. Let me go back to the upper levels here because it's very interesting what the GFS just did this morning, and it can still change, but I do want to show you what the GFS is showing. Oh, I need to go. Let me choose the GFS here. All right, so here is that energy that we're going to be dealing with. And look at this. You have a neutrally tilted trough. It goes from north to south. But then look at this. As it approaches the coast, you start to get a negative tilt. And look at that. You have flow out of the south and southeast. And that's going to drive the storm back and up and along the coast. And look at that. You have a negatively tilted trough up here, driving that storm back into the coast. And let's show you what it looks like at the surface because, guys, this is impressive. Look at this. Look at this. You get snow all the way from Philly into New Jersey, into New York City, and even into Boston, into Maine. And it's a very, very close call for this one. I mean, if you can get small differences in the modeling will make a huge difference at the surface. So just because the European is showing it missing just by a hair, I mean, it's razor thin. It is razor thin. The European on the next run could easily begin to start showing what the GFS is showing, but it could also go the other way. The GFS could back up and start showing an offshore solution here too. It's really going to be dependent, and I want to show you again one last time. It's going to be dependent on the shape of the trough and where the energy gets guided. So look at this. Like I said, GFS, this is the energy. Look at the tilt of the trough, negatively tilted trough. That guides the storm back up and along the coast. But with the European, I'm going to show you what the European looks like. Neutrally tilted trough, storm goes out to sea. So it's all going to be dependent on the tilt of the trough and where the storm gets guided, but it's going to be razor thin. So stay tuned. If anything changes, I will keep you guys updated. Thank you guys for watching. Hope you guys enjoyed and have a great Wednesday. I guess it is. It's Wednesday. Thanks for watching.